Hey everyone, it's Mrs. Cook. I'm going to run through a few examples that we didn't get to in class today just to try to get your confidence up if that helps. So these are note 6.5A, and I specifically want to look at graphing those tangents and cotangents. So in this one, I know that tangent is sine over cosine. So I'm specifically going to lightly graph the cosine. So really I'm looking at graphing y equals 3 times the cosine of 1/4 x. Okay, so when I do that, I know that my a is equal to 3, and I know that the period is 2 pi over 1/4, which would be 2 pi times 4, so that's 8 pi. Therefore, when I set up my graph, I'm going to set it up as 8 pi on the end, and then 4 pi, 2 pi, and the average of, let me erase that. The average of 2 pi and 4 pi is 6 pi. Okay, now the amplitude. We didn't talk too much about this, but amplitude really is not significant in our tangents and cotangents, and that's because there is no height to the shape of the tangent. The tangent goes from down to up like this. There is no height really when you're talking about the amplitude. So even if you didn't label this amplitude as 3 and -3, you're going to be okay, but I still leave it that way because I'm going to lightly graph cosine here. Top, middle, bottom, middle, top. So once I have my cosine there, wherever I said middle, that's where I'm going to start graphing tangent. So tangent is going to have asymptotes wherever I just said middle. So an asymptote here and here. And then I know the shape of tangent is down to up. So in each of these branches between the asymptotes, I'm going to split them down to up. So here I would go down. I'm going to start by going up here and then down to up here. And again, if you wanted to continue that like there and continue that here, I wouldn't take off for that. I'm just graphing 2 periods. Remember, the period of tangent is just a single pi over b because it does repeat. All right, let's try it again here. So in this one, cotangent, well, cotangent, I'm making myself my little note, cotangent is cosine over sine. So I'm going to graph y equals the sine of pi halves x, and then work out all the details from that. So amplitude is 1, period is 2 pi over pi halves, or times 2 over pi. So those pi's would cancel and just get me 4. So I've got 4 here. Gosh, there can be a better number than 4 to get those 3 pieces. So I do label the amplitude, even though it really doesn't have that much of a significance. The only reason I'm doing that is because that guides me now when I wanted to graph my sine. And sine snakes from the middle, top, middle, bottom, middle. So I can lightly graph that, but I'm really just concerned about those middle pieces, because when I graph cotangent now, wherever I just said middle, that's where I'm going to be giving my branches, or my asymptotes is what I should say, asymptotes. And then I know I always want to make a note that cotangent snakes downwards. So I kind of like to make that little note by the problem so that when I get to the big moment, which is breaking the asymptotes, those pieces in between, with these snakes that go downwards. Okay, and they kind of curve right in the middle at that middle line. Again, there's no height to this cotangent, so if you didn't label that one and that -1, you'd be okay. I only do that to guide me when I'm graphing the sine. Okay, hardest one, here we go. I am going to note that cotangent is cosine over sine, and I'm going to concern myself with the sine graph. So I'm going to lightly graph that y equals -4 times the sine of 1/2 x minus 2. Let me figure out all the features. So I know that the amplitude is 4, but that it's going to be flipped. And then the period is 2 pi over 1/2. Well, divided by 1/2 is multiplying by 2, so I get 4. Oh, look at this. I've got a k value this time equal to a -2. Let's see what that does. Oh, finally, wait, before I see what that does, I'm making myself a note so I don't forget that cotangent is going to snake downwards. So normally cotangent snakes downwards, but because it's a negative cotangent, I'm going to have branches that snake upwards. So keep that in mind here at the end. Okay, I have everything I need to get started. Let me go ahead and graph this. Period was 4 pi. And so I've got 2 pi, pi. That was pretty nice as well. 3 pi. Now, my k value was down 2. So wherever I say middle is going to be down 2. So this is my middle line. That's my k line. From k, I go up and down a. So I have to go down 4 and I have to go up 4. That means that the highest point I'll get to is 2, and the lowest point I'll get to is a -6. I've had students that actually like to kind of graph the lowest and the highest. You can certainly do that if you want to. I don't want the graph to get too complicated, though, so if you don't like to do that, you certainly can just keep that in mind for your high and your lows. Really, the highs and the lows only affect right now when I'm lightly graphing my sine graph. Remember, sine was in the denominator, so that's why I'm concerning myself with sine. And I had to flip it. Oh gosh, there's so much to think about. So sine says middle, bottom, middle, top is up at 2, and then middle. That is not the middle. See, I told you there's so much to think about. Middle, thank goodness I drew that middle K line to help me catch that, is right here. All right, so lightly graphing that, and I only care about where I said middle because this is cotangent. So wherever I said middle is going to get some asymptotes. So middle was here, middle was here, and then the middle was here. Now remember, the middle line is where that snake kind of curves. What I mean by that is in between this middle and this middle right here is this middle here. That's going to be my guide at pi that I'm going to snake from down, because this was negative cotangent, to up. Okay, in between 2 pi and 4 pi, I had 3 pi right here at the middle, so that's going to guide that kind of curve to snake upwards. Okay, if you want to meet during asynchronous time tomorrow, let's do that. That would be awesome. Good luck to you as you work through your e-text.